So now, without further ado, I'd like to welcome Arno and John so they can introduce themselves and begin their presentation. Thank you so much.
Thanks, Bruna. Hi, everyone. Thanks for joining us today. It's a very exciting time for AI and especially Agentic AI, and you will learn a lot about it today. So stay tuned, and we'll tell you all about how we achieved this remarkable position here, #1, for over a month now. You can go to the Gaia leaderboard yourself to check it out some more. You see the yellow bar here is 65% accuracy. So 2/3 of the questions are correctly answered. And those questions are quite complicated. And John will go into much more detail later. I joined the company 11 years ago, and I have a background in physics and supercomputing. And John and I both spent the last 7, 8 years together working at H2O on automatic machine learning, driverless AI, and then now on generative AI and the whole system that we're going to show you today. So maybe John, introduce yourself real quick.
Yeah, hi, I'm John McKinney. I also have a background in physics, and I've been, as Arno said, with the company for like 7 years. We've been working together. It's been fun. And yeah, I'm really excited about the announcement that we made for our Agentic AI. And I think Arno will talk a little bit about the company and the whole product suite that we have. It'll be great.
Yes, absolutely. So, H2O started as an open source company, and I was involved in H2O 3 and even a little bit of H2O 2. But, that's everywhere now. 100,000, data scientists used it many years ago. Now, pretty much the whole world has access to open source AI, and we were instrumental in that. And the vision has always been to democratize AI. So faster, cheaper, everybody should have it, right? But the paying customers, of course, are the large customers. We are focused on enterprise AI. So every household name is pretty much using us. The question is to what extent and who's using Gen AI and who's using predictive AI. But luckily, we're converging those two. So we are really putting both sides full front attack on every piece of AI, right? So we have predictive AI on the right side. We have generative AI on the left side. And we're not just doing RAG. We're not just doing machine learning. We're also doing MLOps. We're also doing, procurement GPT, a vertical to help with the comparison of documents. We're doing document AI. We're doing evaluations. We're doing model risk management. We're doing fine tuning. We even made our own SLMs, so small language models, and pretty much everything that you can do that is valuable to the enterprise, we do, and we build products for it, so it helps you get started faster. And the one thing that is special about us is that all of this runs on-prem and air-gapped. So it doesn't have to be in the cloud, but it certainly runs in the cloud as well. And that's how we will do the demos today. And today we will be talking about enterprise H2O GPTe and especially the agentic aspect of it. And I would like to take this opportunity to thank all our customers and obviously all our makers at H2O. We wear our t-shirts with pride, and we enjoy the freedom that Sri, the founder, gives us to innovate. We constantly have to innovate or die. That's the motto here. So please follow us yourself. Go to H2O.ai and then click on chat now, and then you will get to the enterprise H2O GPTe platform that you can run yourself. So I will do that just now. I will go to our website. I will click here on chat now. You can, of course, check it out some more, the website and all our products. And then you should get to this here. And at some point, it will ask you for your Google or GitHub account so that we know who you are and so that you have your username. But I logged in as my Arno Gmail account. So this has nothing to do with our, employee status. This is the freemium version. Everybody has access to it. So now I can chat with LLMs. And here's the little gears here. You can configure it. You can, say which LLM you want to talk to and so on. But for now, I'll just leave it at automatic, and I'll say, how many R's in strawberry? And I'm sure you've heard that before. It should be easy. It's just 3, and even the LLM can do it. Whoops, LLM couldn't do it. Which LLM was it? It was GPT-4o. Could not count R's in strawberry. Okay, well, we'll just turn on the agent, and we'll say the same thing again. And now it will actually use these tools here, and John will go into much more detail. But one of these tools is Python coding, right? And now it's writing a little Python program, And if you look at it, how it's doing it, you can show the thoughts and all that. You'll see it's actually running Python code, counts the letters in Strawberry, and it will probably come up with a 3. So this is how it works. This is the very quick demo of just that, but it can do a lot more. It can actually do all these tools, right? One of them is driverless AI that I mentioned earlier, our award-winning AutoML, and it even nicely, highlighted them for you. But you can make full-blown automatic machine learning model runs all from a prompt. You can literally say, train a model on this CSV, and it runs a full experiment in driverless AI, plots residuals, and gives you findings. And this is not hallucinated, right? This is actually coming from files that are being retrieved from driverless AI. And these are coefficients, evolutions, like all the genetic algorithm that you might have heard of, all the feature engineering, all that stuff is actually done behind the scenes. And all these artifacts are available to the agent. So it has a lot to work with, and the tools that you can configure give you that freedom. Now, if you want to talk to a collection, I can show you that real quick. I have a different setup here. Here in Cloud Dev, this is the latest version. You can see all the different models, by the way. There's a lot of models you can chat with, right? Is it Sonnet? Is it models in, from Google, models from Anthropic, models from OpenAI? Right now, there's a whole list of models, and depending on which environment you're in, you have different models configured. And you can also, of course, compare them and all that. But when you just want to talk to a collection of documents and you ask a question, that's the classical RAG use case, right? And we have a very sophisticated RAG pipeline where you can ask questions and it will tell you what's the answer. And we do this every night. We test the accuracy and so on. So we probably have one of the best RAG systems in the world. And now, of course, we have the best agentic RAG system in the world. And John will tell you why it's so good. But the point is that there is not just one LLM and then a GUI in front, but there is 15 different models that help with OCR, rotation, alignment, orientation, captioning, image detection, handwriting detection, layout detection, OCR models in different languages, embedding models in different languages. There's also prompt templates for different, languages, or funny and sarcastic. You can make these own, you can make your own templates, and then you can ask questions, and it will basically honor these things. And these are shareable. There's role-based access controls and so on. So there's a enterprise-grade system, and this whole thing runs in Kubernetes, is scalable, runs in a distributed system, and you can scale up and down these pods, and you can access control it. Basically, you can say you get access to these documents or these documents and so on. So basically, this is a usable system, and now it's gotten even more AI with this access to the tools that I mentioned earlier that will make the agent really productive. So if we go back and look at what the world can do with all this, you can take documents, you can convert them to JSON, that's kind of document AI. You can take the documents and rewrite them to different languages, fine. You can ask questions about them, but you can also say, go fetch me some, documents from a database, or make some SQL queries from a database, get the tables back, figure out how to combine them, give me some insights, then maybe train a model on it, and then put that thing into production, and then make an endpoint that you can call, and then make me an app that calls this endpoint and visualizes it. All that is now possible, right? So the enterprise is getting a massive boost in AI, and most people are, left behind, have no idea what's even possible and how to do this. And we are literally doing the fight in the trenches, as you want, if you want to say that. We are every day fighting with the reality of the incoming models, the reality of the change of the landscape, and the requirements by the customers, right? So to summarize, GPTe is our enterprise generative AI platform that has agentic capabilities, but it can also do multimodal audio and vision analysis. It can create JSON. You can tell it the JSON schema, for example, and then it will really just process documents into the exact format that you want. You can have citations where the truth came from. You can have custom guardrails. You can have automatic model routing. We automatically figure out which model to use based on accuracy and speed and so on of the real-time systems. There's an evaluation framework. There's a model risk management framework. And these slides are just here to show you roughly what's possible, right? Like, so the references, that's table stakes now. Everybody will know where was the information found. The LLMs themselves are not useful. They're only useful if you give them data, right? Either from the APIs or from documents. And then the guardrails are configurable. You can say, I don't like this customer. I want to only talk about all other customers, or and so on. They can really define these guardrails. And these are all enterprise features. And for example, here, this is the marketing mock-up of the actual truth. This is the table, and it processes it like this. The LLM literally looks at it in many ways, right? Not just the text form, but also the vision form. And then together, it makes a JSON conforming to the specific JSON schema that you wanted. And the same is true for, the visual models. They're getting better and better. They're not quite there yet, but at some point you will be able to basically see whatever the human sees, the model can see. And it can really just convert a chart into, let's say, a piece of code and say, this is the codified version. So this will all help with automation to make your data better. And there is the topic model that's being presented, was presented yesterday in Washington, I think, or in Georgia, Atlanta, sorry. And there it was the model risk management team that presented how they're doing, traceability and making sure that everything is calibrated to the human. Once you see that there's like not enough, points in this corner here, then there's maybe not enough evidence to make statements about it. So if you ask the LLM system, hey, what's going on in this corner of space, and it will say, oh yeah, maybe this and that. It will hallucinate. It will not have enough information. And you can visually, confirm that you have enough documents about any particular topic in this approach. That's also shipped out of the box. Now, I showed you briefly that it can call driverless AI, but obviously it can do other simple things like making plots and so on. And you would think that's now table stakes, but even GPT-4o has problems sometimes, right? They can't actually plot stuff because maybe don't have internet access and so on. So the controls of how to get to data and how to get to your data in particular, that matters a lot. And the robustness and fault tolerant of this tool system, where it tries and tries until it succeeds, is key. And as I showed you earlier, driverless AI is our flagship predictive AI platform. And we have others like Hydrogen Torch and fine-tuning for LLMs or SLMs called LLM Studio, Enterprise LLM Studio. Those tools will all be integrated into the generative AI platform. So you can just literally say, fine-tune, me an SLM on this data set, or even make me a data set so that I can then later fine-tune. And so that these things are happening. It's actually not a pipe dream anymore. It sounds maybe a little bit crazy to say it like that, but the logic is there, the code is there. The only question is, when I say make me a data set, what does it really mean? Like how many rows you want and so on. So you need to have some more human control along the lines, but you're not going to have to manually code all that anymore. Okay. And now we're back to this chart, and I'll let John take it from here. Give us some more insights, please, about the amazing work you and your team have done. Thanks.
Thank you, Arno. So I'll share my screen. Make it full screen. Right. So yeah, thanks for attending. And yeah, we're really excited about the result. It was pretty much done in a short order, maybe a few months, that we realized that we had something good. And so let's talk about it. So let's first talk about what Gaia is, and we'll go into some examples and everything. Gaia is just a benchmark, and there are many benchmarks out there, but why should you care about this one? Well, first of all, it was created by Jan LeCun, one of the wonders of the world in AI. Hugging Face, AutoGPT teams, AutoGPT team, that their repo has something like 170,000 stars, really big project. So they created this about a year ago, and they wanted something that was more real world, because that's what Jan LeCun has basically considered as the flaw with a lot of benchmarks, if they're kind of artificial. Now, the challenge with this one is it's not just that it has, say around 500 questions. Why only 500? Well, they're all very difficult, and they require some number of steps, maybe up to 50 steps for a human to do. And they focus on practical AI capabilities. So things that businesses actually need, instead of something like what you may have heard of Arc AGI. This is just like IQ test for LLMs based upon visual IQ. It's not really relevant for businesses. So in particular, our vision is similar to what Nadella has said, which is that a lot of SaaS applications don't really need to exist soon. That is, you could pretty much replace a lot of SaaS applications, including a lot of the Microsoft platform, with an agent that just answers your questions directly. And it can be a visual agent, something that's not just text or audio input, but even builds the UI for you while you're talking to it. And this is already happening. So in the end, the end game seems that we need these kind of AI agents because there's a labor shortage, but also we want to be able to offload a lot of the kind of nastier tasks to AI that take us too long, that are kind of repetitive. And as we stack layers more and more, we can get rid of more and more of these tasks. But we want something that is really for business. In particular, it needs to be something that's practical. And we also want to make sure that whatever is built is something that doesn't just become obsolete every month with a new LLM, something that can scale. So that's what we tried to build. And we primarily are going to focus today on our use of Anthropic's Sonnet 3.5. And with prompt caching, we were able to get about 90% reduction in cost because of the AI way our agent works. Yeah, and of course it has lots of tools and other things. We'll talk about that. So let me also break down Gaia a little bit. So Gaia is composed of level 1, level 2, and level 3 problems. And you can see across the board, even though we have a good score of 65% accuracy overall, it's true for each one, roughly 15% boost compared to Google, which is the Langfun agent. And that's great. So it means that we have something unique here. And I'll give you an example of level 1, level 2, level 3 questions below. And we'll look at one of those level 2 questions, and we'll look at another level 2 question. The level 3s take a little time, so maybe 20 minutes, so we don't want to go into detail on those. And the level 1s are a little bit too easy, let's say. So yeah, let's take a look at these. But first, let me give you a big overview. What are we doing? What are we building? And this is OpenAI's version of what they consider to be the progress of AGI. So of course, we all know about chatbots. They've been around for a long time. ChatGPT made it something that's quite useful to the world. And this year, the prior year, 2024, was sort of the year where we realized that we can build reasoning models with O1. And amazingly, the Chinese company DeepSync has made R1, which is competitive with O1 and is actually open source or open weights. And people are able to reproduce what OpenAI has made now. And so that's great because you can use these kind of technologies on-prem as well without paying OpenAI all the money. And I think this year, everybody kind of has been touting this as the year of agents, where a lot of what is expected of level 3 for OpenAI's AGI definition will be realized. That sounds like a lot, but just think, it's only been a couple of years since ChatGPT came out, and the progress is just hard to manage, hard to appreciate, really. Now, in the big picture, also, we participate ourselves in different levels of the stack, of the AI stack, but we don't do hardware. But we do have a cloud, we do have foundational models, orchestration layer, and of course we have our agentic platform, H2O GPTe, and you can build applications on top of H2O GPTe, which our customers are doing. And I'm just showing this to show you that there's a large number of components here, and we're only going to today focus on the agentic platform for H2O GPTe. And there are many kinds of agents, right? So just to give you a little bit more background, their original style of chatbot was like zero shot. You ask a question, you get an answer. And you could do RAG, which is kind of like what we call few shot or mini shot, where you're putting in a large amount of documentation and you're getting out your answer. And it becomes grounded in that content. But what if you could ground the LLM in the real world, in tools, in content that it can access, in coding, which is it's either, the code is either right or wrong at some level. It can look at the output of the code. So once you can give it some more grounding, it really opens up the opportunity for LLMs to even do better. And ultimately, the goal is to have a AI coworker, to have something that continuously learns. It is able to understand your company or understand you and act on your behalf. And that's a big challenge. That's what's going to have to be difficult and solved. So just to give you an overview of the software I'm going to be talking about today, we have H2O GPTe. Its primary focus is on enterprise AI. And like Arno covered a lot of the capabilities, but it's currently the highest in this generalized assistant benchmark, which is one of these things we'll talk about the kinds of detailed tasks in a moment. There's OpenAI operator, which is more like a mouse and keyboard system. We have semantic kernel, Llama index, cloud computer use, H2O GPT, and I think many others. And I think the key thing is that there's certain of these that are platforms for development and other ones that are applications. And the key problem with a lot of the development kits is that they're not really benchmarked. You don't really know how well they do until you try them. But other ones, and a counterexample to that is like what Microsoft did with AutoGen. They created Magnetic 1 and they actually benchmarked it. So that's a unique example. And Google LangFun as well. And in the end, whatever generated this output, it actually said, well, for enterprise deployment, you probably want to use H2O GPT or Microsoft semantic kernel. So the reveal is that all the prior slides that I've shown so far were actually created by H2O GPTe agent. So what do I mean by that? Well, so here's the query, the simple query I asked when I wanted this table of information here. So all these details about percentages, I didn't do any of that. I didn't put in the monthly payment. I didn't put in the GitHub stars. And it's able to generate all this information just from a single prompt. And it takes about maybe 5 or minutes, maybe at most 10 minutes, depends. So you're saying, well, John, maybe other products do as well. Let's look at that. Let's look at how other products do. So this is OpenAI operator. We could show the video, but there's not a lot of time, so I'll skip the video part for this. But basically, it takes about 8 minutes. I don't know if you can see that, but it's doing it all in the browser, and it opens up a bunch of tabs, and it's trying to find the information. So it's trying to find what are the most important agent platforms, ACK packages, and I give it some examples. It should go find them. It should include benchmarks like Gaia and capabilities and other interesting aspects. So did it do it? Well, there's a couple problems here. First of all, if you look at what kind of table it made, it's extremely sparse. It's almost useless. It doesn't have any details whatsoever, even though it took all this time. The other thing is that it's a poor UX. You can see that it opened a new tab and it put the markdown in there. And now I have to go to like Dropbox or Google Drive. I have to log in and then access my Google Drive on their systems, which seems insecure, and then be able to get that document somewhere. So it's a really poor UX, I think. But it also didn't do a good job. So this is another issue is that once you are done with operator, and if you come back to it later, the conversation is closed. What that means is that you are no longer able to iterate and ask a follow-up question. Maybe they can improve that, but it's overall not good state right now. And this is what the final table looks like, just to show kind of zoomed in a little bit. It's all very sparse. Okay, well, let's try ChatGPT. So ChatGPT does a pretty good job. It looks like it's filled out a table. It's much more comprehensive. The problem is twofold. One is that if you look at the sources, you can see AI starter kit, starter guide, AI starter guide. You can see it everywhere. So essentially, ChatGPT is relied on a single source for all this information. And you can see it down here. It says maybe a couple sources. And that's not very good. I mean, probably all this information basically came from one website. So it's not really ChatGPT doing the work. It's really just scraped one website. And is that trustable? I mean, it just happened that the benchmarks were not specified, but it didn't make any effort to go find them. It didn't think, oh, well, it's not specified, so let me go do what the user wanted. It just gave up. So it may be fast, but it's very shallow. It's not deep at all. So that's a problem. So DeepSeek is interesting. DeepSeek has their own version of ChatGPT. In fact, I would say that it's much better than what OpenAI has. you can see that it has many more citations, and the benchmarks are at least filled in some sense. It doesn't actually do a good job like of being clear maybe about the benchmarks, but it at least has something that's not just not specified, right? It actually did some kind of more comprehensive search. And I think this is a lot of what people have said about ChatGPT search is it's just not really good, and you really can't trust it, especially if it's only checking one source. So yeah, and we don't have this kind of nice side panel right now, but we're developing this kind of more visual way of representing the links that we search. I think this is a good use case, a good UX there. Now, okay, Google Deep Research is also interesting. It's also a product that allows you to do this kind of activity. And you can see here, it looks pretty nice. You can open it in Word or, Google Docs. The problem here is that while it did kind of specify the benchmarks, it's very sparse information. But it's not too bad. It took a lot longer, maybe about 5 minutes to produce this. So it took about the same amount of time, but it's a little bit less information. But I do like what it says. I do like how it says that, if I zoom in on this, converging AI paradigms. H2O GPTe's innovative approach of converging generative and predictive AI could lead to more accurate and reliable agents. So that's true. So I think Google has called out a very important point, is that not a lot of companies focus on the combination of generative and predictive very well, but we do. And I think that's one of the reasons why we've done so well. Basically, best data science practices can be put into play. So now we'll look at some actual prompts in a moment. I just wanted to give an overview of what the agent's actually doing. This is the high-level overview. This is just showing, basically, you get your data, you set your prompts and your system prompt, you maybe execute some code using some tools, and you show the info. You'll have some guardrails that protect that information from having any secrets, and then you'll deliver that. Okay, that's a very high level. Now, so this is a little bit more expanded. Don't be overwhelmed. I'll go through it verbally. Basically, as a user, you can choose accuracy. You can choose how long each turn should take. All of these complicated expert controls can be put in. You have your query as a user, documents, images. It all gets put into some kind of input. And then we take that input and we give it to the LLM, and it needs to come up with a plan. And then once it has that plan, then it goes into what we call the conversational agent. If you're familiar with AutoGen, you'll know that term. And this thing writes code. And then there'll be a loop, an iterative loop, where it goes back through and executes that code. And you could call it 2-agent. I think AutoGen, they call it 2-agent. I wouldn't really call this an agent. This is just another tool. But the real agent is just a single agent. And it eventually gets done with that somehow, and I'll explain. It generates a summary, checks for security, make sure nothing is leaking out, nothing bad happened, and then returns the information to the user. So, and that could be, the history of what the conversation was, the generated files, and the summary. So I'll also go a little bit into the conversation flow. So when the agent starts up, it of course generates code, executes code, and then we have a step, many steps in there, where it might decide, and it's not really shown super clear here, but it might decide at different levels of accuracy what to do. In the simplest accuracy, it'll just basically avoid the self-critique and go to an assessment of, did it answer the question, and then finish. If you crank up the accuracy to maximum, then it will eventually, once the model has no longer any code present, that's what I mean by code present there at the bottom. Once there's no code present, it'll make sure, well, did I stop too early? Did I stop within the first 10 steps? That's probably something's like a little bit too soon. It's a little bit too soon to stop. If it has, then it continues. If it's not too soon, then it goes to asking if there's a critique that can be made. And if the critique is made, then it will continue, maybe write some code after it realized some mistakes, and eventually get done with that critique. And then we ask the LLM if it needs to use the advanced reasoning tool to do any kind of a check of the output, and like whether it needs to format things right or not, some tricky issues with formatting perhaps. And then we ask it to create the final answer. So it's not complicated. It's roughly speaking, input, did you stop too early? This is in the agent accuracy mode of maximum. Did you stop too early? If you did, keep going. And if you didn't, then do a critique of what you've done so far. If it keeps making code after the critique, keep going until it makes no code. As soon as it makes no code again, then you're done. And then just tell it, okay, this is how you write your final answer, and it will consume that. So it's relatively simple. Now, there are challenges with all this. One of the biggest is hallucinations, and I'll talk specifically about that in more detail. But there's context management. How do you manage all this context that could be created if you're pulling in a ton of documents? And if it was a single LLM doing all that, you're going to lose your context length. How do you choose the tools? How do you make sure the model is responding coherently? How do you coordinate the different tools together? All these are quite difficult. There are some more medium level challenges, like an example is, I mentioned the output sensitization, making sure that everything that goes from the user to the LLM has safeguards, guardrails for whatever the user is asking the LLM to do or code to be executed. Then the LLM is generating something that maybe has code that shouldn't be executed. And then once the code is executed, we have an extra protection to see if that output was any kind of secrets or any kind of problems with the output. So there's output guardrails as well. And in the end, after everything's done, there are files being sent back, and we have guardrails on those. So there's guardrails everywhere. And that's more of a medium challenge. And of course, there are many easier challenges, all the API integration, building the tools, and configuring all this. Those take time, don't get me wrong, but they're relatively easy in the grand scheme of things. It's more simple engineering. Okay, well, let's look at hallucinations. So the interesting thing about hallucinations is that they're an unsolved problem. And if you could solve hallucinations at some level, it would be great. Now, hallucinations, to some people, they say that's not a flaw. They say, well, it's just creativity. It's not quite true. There are clear cases where it's basically making up stuff. And this is an example of that for the agent case. And you have to solve these, or else you're not going to have a reliable agent. And most platforms don't solve this. I think maybe almost none except for ours directly attack it. So in particular, you might have a question. I show that in green, and then the coder agent, remember that's the LLM, says, okay, you've given me all this information, all this input files, everything. What should I do with it? And it comes up with what it should do. It wants to write some code. So in this question, it's something about PubChem. It has to go to the website and figure out some kind of complicated chemical thing. This is one of the Gaia questions. I think it's level 3. I'm not sure. So it says, okay, let's search for the compounds that match that criteria. And it'll write code. And I don't show it here because it's an HTML, but this is all within like code block. It's like there's 3 backticks on the code block. And so we can identify the code block very easily. And we could say, well, okay, that's great. So let's execute that code. But no, it's not done. The LLM is still continuing its response. It's wanting to do more in a single response. It's like if you ask ChatGPT a question, it keeps just outputting stuff. Now, what is it outputting? It's saying, well, let me analyze the results. Well, you say, well, that's not so bad. I mean, I can run each of these in turn sequentially. So maybe just trying to be efficient. That's okay. That's not a hallucination. But the problem is here when you get to the next part in red, which is still part of the same output response, it says based upon the analysis. Well, what analysis? It's never actually run any code yet. What is it talking about? It starts answering things that never happened. And it continues with a follow-up piece of code. And it says, okay, well, after analyzing the data, it never analyzed any data. It completely makes this up. And it even comes down to the point where it makes up the answer at the very end, this 8059, which is the wrong answer. So why did it do this? And what model is this? Is this a crappy model? No, this is one of the best agentic models out there. It's the Claude Sonnet 3.5, the new one. As you look on the Gaia leaderboard, this is the one that's ranking at the highest, including ours. So the best models can hallucinate. And if you don't counter this, you will get wrong answers. You will get wrong code flows, wrong workflows. So I can give you the simple, like of all those laundry list of challenges, I will show for this case what we do. And it's relatively simple. There's one thing you can do for hallucinations that's simple, and there are like another 20 that are a little more complicated. So for this case, it's relatively simple, right? You reject all of the stuff after the first code block is written. If it generates multiple code blocks, you just remove them. So you terminate basically the conversation after this first code block. And then you execute that code, and then you let the LLM get that output, and then you go from there. So this is a way of allowing the LLM to avoid hallucinations and this sort of false follow-up that it happens, which is kind of an agentic form of hallucination. Okay, great. So we know how to solve hallucinations at some level. Let's actually look at a query. So this is a query that we'll look at in more detail. We'll look at two. In this case, it says, according to this website, what's the difference in unemployment in percentage in the US in June 2009 between 20 years and over men and 20 years and over women? So this is asking basically the percentage difference for a given month and year for a certain category of group that are unemployed. So it takes your head a second to wrap your head around that, maybe that question, but we'll go through it manually. So the answer is 2.3. So let's actually go through this. So how would I solve this problem? So I got to try to keep the question in my head. I'm looking for unemployment. Okay, well, this is nice. They've already made a chart on the first page. I can say, okay, there's a civilian unemployment rate. Looks like they have, like, what would OpenAI operator do? Like, that's, I have a mouse, I have a keyboard. So, okay, I don't want total, I do want men. Yes, perfect. And women, 20 years and over. And then I have to, operator can't do this, but I can. I can say that women, it was June 2009. Women are 7.6%. Hope you can see that. I can make it a little bit bigger. Yeah, that's perfect. So for June 2009, women are 7.6 and men are 9.9. So that's a 2.3 difference. Now, how is an agent going to navigate this? Maybe OpenAI operator could, but it can't. But okay, well, let's download this. No, I don't want a picture version. Okay, well, what if I go to read more? Well, it's the same plot again. Show table. Oh, this is nice. Yeah, okay, this is good. So let me just verify June 2009 in the middle here. Let me make it at the top in case you don't see my mouse. June 2009, and I think I need to see the columns again. Men 20 years and over, women 20. Okay, it's those second and third columns essentially. Okay, so June 2009, 9.9 and 7.6. Perfect. So 2.3% difference. Okay, that's great. So I know how to get the answer. Okay, then it took me a little while, right? And I've actually done this before. I didn't, the first time I did it, it took me a little longer than it just did. So now let's look at what H2O GPTe does. So we just put the prompt in, click use agent, go. And in this case, I'll show a little bit different next, but in this case, I'll just show that you don't touch anything. It shows like a summary view of what it's doing, and it shows you all the tools that it's utilizing. And this is useful. And you can see that the timing, it's only going to take about a minute to do all this, much quicker than I did. And it doesn't have to use the mouse and keyboard necessarily. So it's going to take about, I'm going to skip to the head. You get the idea that it's going to take about a minute. Okay, it's finishing up. It found 2.3 percentage points. Great. So, and you can look at the files and it shows all these details about the files. Now, okay, that seemed like a relatively simple task. Well, let's try, so it's not, yeah, there it goes. Let's try a more competitive product, like say, Google Deep Research. So you can see here I've gone to gemini.google.com/app. I've chosen 1.5 Pro with Deep Research. So let's do the exact same query, but with Deep Research. So it says just a second. So in this case, it's formulating a plan, and it's nice. It does a little bit of a human in loop where I can click, review the plan and edit the plan and start it. So we're adding that as well in our product, that kind of human in loop thing. Now, the problem with human in loop is that, as I mentioned, it's a little bit difficult to know for an open-ended problem what the plan should be. So you really can't just go by the plan. You really have to have some kind of way of navigating the world. And that's what a general assistant should do. And that's what H2O GPTe does. Now, when I did this, I noticed here that it got kind of stuck. I really don't know what's going on here. So that's the nice thing about H2O GPTe is it constantly shows you progress. And here I'll skip ahead a little bit. Again, I was staring at this and for like a minute and nothing's happening. Okay, finally something new websites appeared. And eventually it's stuck again. I don't know what's going on. It's like 3 minutes by now. What's happening? Lots of confusion. And I'll explain something in a second. Okay, finally, is it going to do something? I'm racing to the end so I can skip the boredom. Okay, research unsuccessful. So this is a problem, right? So at least you want a product to not fail. So in this case, didn't answer the question, but it literally failed in answering the question. Just completely outright failed. Now, there's also confusing hanging periods during. It seemed like it was making progress, and you have no idea what's going on. So this is a problem. Now let's use another tool. So this is Operator. So this is like OpenAI's first agent. So it's OpenAI, right? It should do great. And unfortunately, you can see if you look at the timing here, I don't know if you can see that, but it's going to take about 15 minutes, and it's not going to get the answer right. So I can't show the whole 15 minutes in this talk, but you can try it yourself. And I'm going to skip ahead to a certain point a little bit, about 5 minutes in, 6 minutes in, and you can see it's done a lot of work. Imagine paying for all these tokens. It's not going to be good. So you can see here what the main thing that you can see here in this particular case is it doesn't know how to use the search engine. It keeps trying and trying to put in something for the query, and it keeps having no records. I've seen that in my own work where filling in the search engine is not trivial. It's not Google search. It's not as usable as Google search. A lot of these, company specific search engines. So it's not able to do a good job. And in other cases, it gets stuck in loops for clicking on documents, and it can't find the right documents. It's quite bizarre to watch. It's much worse than a human. Now I'm going to skip ahead because it really is too long how many mistakes it makes. And eventually it finds data, but it makes up some kind of the normalization of the data. It's not actually the correct percentage. And in the end, it gets done and it comes with 1.55, which is the wrong answer. So after taking 15 minutes, it got the wrong answer. It's a waste of time. You can see clearly in how it's behaving that it is not doing the right things. Okay, so we have these 3 results for this query. We have ours, which is correct at 2.3%. Google Deep Research failed, and Operator also got the wrong answer and took too long. Now, I want to clarify. This is the very first, I was preparing this, say, yesterday, and this is the very first query I tried. I didn't, I didn't cherry pick this particular question, for one. I didn't cherry pick my Gemini Advanced or my Operator experience. These are the very first attempts at using deep research and my very first attempt at using Operator. And my very first attempt, of course, at using H2O GPTe while I was preparing for this talk. So I think this shows that our product is quite reliable and accurate and fast. It doesn't waste your time. It's going to find the right answer in a lot more cases than any other product in the world. So let's look at another query. So this is more about, it's not data science, but it's more along that direction. You have some kind of Excel document, and the question is, the attached file contains a list of vendors in the Liminal Springs Mall, along with each vendor's monthly revenue and the rent they pay the mall. I want you to find the vendor that makes the least money relative to the rent it pays. Then tell me what is listed in the type column for that vendor. Okay, so here I'm showing a snapshot of that Excel page. Now you can see here we have revenue and rent, and clearly, of course, you have to wrap your head around this question a little bit, but I've thought about it before, and it's not too bad. So you want the revenue, the least money for the rent. So you can take revenue divided by rent and look for the smallest, for example. So let's actually go do that. So here's the page, and I'm going to do what I said. Well, it's easy, right? So I just take the revenue divided by the rent. And yes, please autofill for me. I'm going to get rid of these like spaces. It just looks bad. And can I go ahead and see it? What's the biggest percentage? No, the smallest percentage. So we want yes, that's what I did. Revenue over rent. So the least, maybe it's this one. Yes, it's this one. So 62% is the smallest. And what is the question again? I need to find the type column for that vendor. Okay, type column for this vendor is finance. Okay, perfect. Answer is finance, correct. So, okay, we as humans can do that. You have to be able to, as you can see, not just understand the question, which is a little bit, not too hard in this case. It's a level 2 question, it turns out, in Gaia. So it's not the hardest level 3. But you can see you do have to use Excel. And you should say, well, of course, every advanced agent platform out there or research platform out there should be able to do this. Unfortunately, it's not always true. So this is H2O GPTe. Just put in the prompt, click it, use agent, go. And in this case, I'm going to show the thoughts. So I'm going to show that you have full access to everything that the LLM produces, and you can use the code. You can see exactly what it's doing, and you can see how it makes mistakes, and it'll figure out how to fix it. And unlike deep research or the other products like Operator, you have really no idea what kind of code it's making and what it's doing in the background when it hangs. You don't know why. So this is one nice thing about our platform. It's exposing these thoughts. Like OpenAI likes to keep everything secret, but we think that it's very helpful as a user to have trust in the product when you actually see what it's doing, and so it's not making things up. It's not, and you can actually reproduce it using the same code that it generated. Okay, so it's really only about a minute, and it's figured out, okay, great, finance. It figured out that the answer was finance, and it gives you a little spiel about that fact. Okay, well, let's try other things. Let's try Google Deep Research. What does it do? I'll put the exact same query in. Now, it took about 3 minutes. I'm not going to go through the whole thing there. So I'm going to skip ahead. Like there's a plan as usual. There's some websites. In this case, it didn't fail. That's the good thing. But it did take about a minute and a half. And I honestly, after all this output text, it's a really strange answer because it's talked about hot topic. It said it was determined that hot topic is the lowest ratio. If we go back to this thing, we say, is there any such thing as hot topic? There's no even hot topic. What is hot topic? It's hallucinating something. I don't know what it's hallucinating, but it's hallucinating something. Let me go back to the presenter view. So let's go back to that. What is it doing? Yeah, it's somehow doing some kind of hallucination. Well, I'll show you the final answer and we'll talk about what it may be hallucinating. So let's see if this next one will go. Come on, Google. Okay, there we go. Now let's try Operator. Again, supposed to be very advanced. It's just a few clicks, literally just a few clicks. Yeah, thank you for Aaron. But it's not in the Excel page. Good question. It may be founded on the internet, but it didn't follow the user's query, right? So it got blocked. OpenAI Operator is blocking this URL. It can't ingest a simple URL. And that's the end of that story. There's nothing else the operator can do. Okay. So we have our answer, finance. We have Gemini Google Deep Research. It says, according to the provided data, the type for hot topic is clothing and accessories. Oh, okay. Is there even clothing and accessories? Doesn't exist. It's not even here. So it's a pure hallucination. It might have found something on the internet. It might know something in its head, but it did not use the data, even though it said so. And here's the problem with that. It's giving you recommendations. It's giving you all this information. It really feels authoritative. It really feels as if you can trust it because it's going into such detail, but it's simply wrong. Okay, so let's summarize these different products. And of course, I may be biased, but I'm trying to be honest at the same time by telling you that truthfully that these were the very first queries I did with all these products. I don't have a lot of time to, like cherry pick. I didn't do any cherry picking. I picked one question. I, wrote the talk. I maybe wanted another question. The very first question I chose, maybe I wanted some kind of money related thing. That's the only thing I wanted. Only filter I made. I wanted some money related stuff. But then it's the very first try I did with all these products. Okay, the key thing is that, among all these things, a lot of them do directly answer questions, but some of them don't let you see the progress. Like Google Deep Research, you can see what URLs it's using, but you have no idea what analysis it's actually doing. So for deep research, you could say, well, is Google Deep Research? And the answer is no. As we saw when it was filling out some of the details for the benchmark, it didn't put any numbers. And the reason is what it's actually doing is wide research. And it's just not a sexy name, right? It's not as good. Google wide deep research doesn't sound great. It's really diverse search. So it goes over a large number of websites and tries to in parallel aggregate those and come up with an answer. It's not doing deep research. However, OpenAI Operator is deep. So it is drilling down, but it easily gets confused. It fails. It takes an excessively long time. And it's really not the ideal way to do a lot of information gathering. You don't want to point and click to do information gathering in a lot of cases. You want to just do Google search and stuff. And it doesn't do diverse search. So it is drilling down, but it's not really too broad. It does a little bit broad, but it just fails way too often. And then ours, it's basically for the same kind of queries, instead of failing or taking too long, it maintains high accuracy, but only takes a minute. And I didn't show any complex queries in live, but it can take 20 minutes and instead of failing. Okay, so let's wrap up. Let me just give a big picture view here. Where are we? We're creating AI agents, but this is not the first story in our human automation. All the way from basic arithmetic. Let me make the full screen again. All the way from basic arithmetic to textile to filing cabinets going to databases to, of course, there's video games, there's programming, stock market trading. There's no paper in telephone calls anymore. It's all on computers. We have music and speech recognition that have been solved. O3 has basically beaten the average human in this IQ test for a visual IQ test called ArcAGI. It's surpassed all but the top 200 humans in code forces and code competitions. And so this is great, but what does it mean in the actual workplace? Well, we're believing if it's really the year of agents, that at least in the digital workspace, agents will perform a significant number of tasks in the workplace some humans usually perform. So it's not like it has to be, of course, something that's valuable to the companies. And of course, maybe next year is the year of robots. We'll see. And I'll explain our roadmap. What are we going to create upcoming? So first thing we'll do is we're running our platform on DeepSeek. It's the best open source model right now. It basically is like an on-prem version of what OpenAI or any other provider has. It's quite competitive with Claude. It's just behind it. And so that's very impressive. So you could basically have Claude, if you have our platform with an agent and you have DeepSeek, you have the equivalent of OpenAI or Claude in your own premises. And we'll add more human in the loop, like I mentioned, editing the plan, taking over, editing code. We're basically grew up as a data science company, so we're going to have a lot more data science features that can do advanced EDA, discovery of features, not just create models or give insights about them. We'll have more platform integration. We have driverless AI integrated with the agent, so you can run these other products we have with simple prompts. But we're also including Eval Studio, which evaluates models. We have LM Studio integration, which actually can fine-tune models. All this controlled by the agent. We'll add better UX, so it looks prettier, and you could click on things while it's running, so you could see the URLs it's working with. We'll have the same kind of stuff the operator has for clicking on pages. The key thing there is that we need to fill in forms sometimes or do more complicated tasks, and we need to make sure that we act more like a human so that we're not blocked as a robot, things like that. And of course, more data integration with Teradata, Snowflake, and other enterprise databases. And the exciting thing is, I think, custom tools and agents. So we're building out a framework so that the agent that we've built can build its own tools. You just feed it API documentation, you feed it what you want in a prompt, and maybe some credentials, and it can go build an arbitrary tool to connect to any API. And in general, it can build any tool. So I think it's very exciting. So essentially, the tools that we built, which are mostly from, say, LLMs, like you could say, I'm using Claude to help me with the coding, let's say. Now it'll be 100% built by the agent. And you could customize it for any business needs as well. You can create AI agents overall. You don't have to only create tools. And in the end, we want the AI coworker to be there competitive with humans in the workplace, not just call center type uses that are very popular, but pretty much every use case. Okay, that's it. Thank you very much. Arno, I'll let you share the final screen if you want to talk.
Thanks, John. Thanks, everyone. Yeah, this is an exciting time, isn't it? I will share my screen real quick. Here we go. And just to summarize, I mean, obviously, you've seen H2O GPT agents are amazing, and there's other things you can do with them. You can do document AI, you can do just regular LLM stuff. And the beauty of the system really is that you have APIs, right? Like, but whenever we do something, it's enterprise grade, which means you have REST API, you have Python RPC APIs, you can have JavaScript APIs, you'll have role-based access controls, groups, and so on. You can customize pretty much every part of it. You can even white label it if you want red and green instead of yellow. You can have that as well. The whole thing is running in Kubernetes. It's running in the managed cloud if you want to not have any on-prem hardware, or you can buy your own hardware. You can dump it in a basement with no internet. We'll bring a USB stick, and we'll make sure that it runs for you. And the main advantage really is that the trust is in the open source, as Shri always says, right? Open source is gonna win, and you see that right now, right? DeepSeek has not let us down, and I would say it was expected that open source will eventually narrow the gap, as always, right? Linux is there, not Unix or not Sun. The same thing will happen with AI. In 5 years from now, this will look primitive, right? And you will all have things that are much more advanced, but open source will always be on top. And we will be there to help you deploy that in production. Because it's a lot more than just an LLM, right? You need all these middleware of AI, and that's what we're good at. And I would say, let's try to answer one or two of these questions, John. Like, how did you feel about the DeepSeek thing? Was that a surprise to you, or I would say no, it was expected?
I think what was surprising was that it was at O1 level. So I wouldn't be surprised that something came out, but I was surprised that they were able to match OpenAI so readily and so quickly. I would have expected it to take longer. Yeah.
Yes, and I would agree. It was a wake-up call, as most people are saying, but we've had many of these in the last few years, so we are wide awake. And we hope you contact us if you have any questions, you want to do a demo, you want to just log into that freemium version we showed earlier. You could just go to H2O.ai. It's not H2O, it's H2O, okay? Like water. Water is everywhere, and we're going to make AI everywhere. That's our mission. And thanks everybody for watching this webinar, and we'll see you soon. Take care. Bye-bye.